Now, another type of problem is what we call a work problem. And for this, we need a little background. So let's read and pause. Now, in doing work problems, as we look at the first one, it says someone can wash walls 3 hours working alone. But if they're with someone else, or let's say the other person can wash the walls in 2 hours. But if they work together, how long would it take for them to wash the walls? So this is work. So as we look at Beavis here, I think of Beavis and Butthead. Anyway, that was silly things, weren't it? All right, so what would be Beavis's rate? How much could he get done in 1 hour? Well, his rate, he could get 1/3 of the job done. Let's see here. He can get 1/3 of the job done in 1 hour. And Bart, it takes 2 hours for the job. He can get, his rate is 1/2. In 1 hour, he can get half of it done. Here, Beavis can get 1/3 of it done. Its rate is, in 1 hour, he can get 1/3 of the whole job done. Now, together, we don't know how long it would take. So we would say 1/t. So the rate working together, we don't know that. So we're going to use this t. So what formula can we generally develop with this information for work problems? Well, the rate of one person, 1/3, plus the rate of the other person, which is 1/2, is going to equal 1/t. And that's the equation for this particular example. Now, since this involves fractions, we're looking for a technique to solve this one. So I will take time to solve this one for you. And the rule we said is to multiply each term by the lowest common denominator so that we can get rid of fractions. So what is my lowest common denominator here? Well, it's 6t. Now, I could write it 6t, or I could write it 3 times 2 times t. I'm going to multiply each term by my lowest common denominator, which is 6t. But I've written it this way so perhaps you can get a better handle on it here. So, I've written it once, but I'm going to multiply each term by this. So here the 3 would cancel out, and what I'm left with here, this 3 cancels out, is 2t. Now here the 2 cancels out, and I'm left with 3t. Now here the t cancels out, and I'm left with 6. So I've gotten rid of, and I see my pen is acting up here. I've gotten rid of my fractions. So now I add this together, I get 5t was having some trouble with my tablet here. Okay, but I think we're back in business. 5t equals 6. So t is 6/5 hour. Now that's an improper fraction. If I want to change that, it would be 1 hour and 1/5. Now if I wanted to change that to minutes, that would be 1 hour. And what is 1/5 of an hour? Well, you would go 1/5 of 60 minutes, and that would go 12, so it would be 1 hour and 12 minutes. Again, there's a number of ways to write this, but what we're interested in here is setting up the equation. So since this is looking a little messy, I will clear it up for you. All right, let's go on to number 2. Read and pause. So Eric's rate to do something would take him 3 hours. So his rate would be 1/3. He can get 1/3 of the job done in 1 hour. So the rate per hour is 1/3 of the job. But Mark needs 5 hours to do the same job. So Mark's rate is 1/5. In 1 hour, he can get 1/5 of the whole job done. How long will it take them if they work together? Again, we're following that work formula. It will be 1/t. And again, to do this, since we'll get some practice in this, what will be my lowest common denominator here? Well, it's going to be 15t, but I would do it this way. 3 times 5 times t. So here the 3's would cancel out and you would get 5t. Here the 5 cancels out and you get 3t. Here the t cancels out and you get 15. So this is going to be 8t equals 15, and then t will equal 15/8 hours. Working together, it'll just be under 2 hours. This is going to be 1 hour and 7/8. Okay, so you see these are very similar. We'll clear this, and working alone, well, let's pause and read. Now, this one is different because they're saying if it takes Jacob 5 minutes longer to wash the dishes than it takes Sarah when she works alone. So what is Sarah's rate? Sarah's rate well, we don't know Sarah's rate. So we're going to say her rate is 1/t. And now we're dealing in minutes here now. We don't know how many minutes it takes for her to do it. But if working alone, Jacob takes 5 minutes longer than it takes Sarah. So we know that person's rate is going to be t plus 5. And they're saying if they work together, though, they can do it in 6 minutes. So this one's a little different. So here we know the working together rate is 6 minutes. We don't know what this rate is, but we know this person's rate is 5 minutes longer. Okay, so there's our equation. And for this, you might say, what is my lowest common denominator? So again, these are a little more challenging. And again, I would write it this way. I'd say t times t plus 5 times 6. So here the t's would cancel out, and I'm left with 1 here that I would have to multiply these two together, and it would be 6t plus 30. So this t cancels out, and then it's just 1, so it's 6t times 6t, and then 5 times 6 is 30. Okay, so the next one then is the t plus 5 cancels out, and I'm just left with 6t. And it looks like this is going to be a quadratic equation. And we don't do quadratic equations, so this one is a little bit more advanced. But the t would cancel out, and this would be t squared plus 5t. Okay, you wouldn't be able to do this one in this course. This is for the next course. We'll give you a little preview of what's up ahead in the next course. We used to cover this in our Math 1103, but we've collected like terms. Now we put all of our terms on one side, so we get t squared minus 7t equals 30, which is a trinomial that we look at in Chapter 5. And how did we get this? Well, we got this trinomial by foiling two binomials. So we're going to factor this trinomial into this. We get the factors. We equate each of the factors to 0. And we get t equals a negative 3, and we don't have negative time. And we have t equals 10. So 10 happens to be what t is. So how long does it take Jacob to wash the dishes by itself? Well, it takes him 5 minutes longer than Sarah. Sarah takes 10 minutes, so 10 plus 5 would be 15 minutes, but you wouldn't have any like this. In fact, I don't recall that we had work problems in our lessons, so perhaps we're getting too far ahead of ourselves. All right, we'll wind this up now.